Hi class, we're going to take a look at problem 2. Now, in problem 2, we're actually told the following. We're told to assume that the data is actually bell-shaped. So we're still talking about the same basically problem, which is the text messages. And if they're telling us that the data set is actually bell-shaped, then what actually kicks in here, it's the empirical rule. I basically screenshotted all the information for the empirical rule. Remember that within the empirical rule, we have these percentages practically in stone. And then the first question that they're asking is for us to find the usual interval. So the usual interval within the empirical rule, we're talking about, in this case, the 2 standard deviations away from the mean. We are also told in the problem that this happens to be a sample. So our interval is going to be evaluated as follows. So in this case, let me just say that the interval is technically x bar plus or minus the values of 2s. The empirical rule is stating it for a population, but since we have a sample, so if we had been told it's a population, we're using the mu and the sigma. But since we technically have a sample, we're going to be using x bar. Also, I already typed in the values, and the actual x bar, which happens to be the sum of the x's divided by n, here it's being, we're getting from the lab 19 output a total of 25 and a little bit of cash. So let me just rewrite the formula. We ended up with 25.6868, and let me go to 3 decimals. So that's going to put an 8 on the next value. And then the standard deviation, in this case s, which is equal to the square root of the sum of x minus the mean squared divided by n minus 1. This is going to be 11.59. I'll go to 7, which is 3 decimal places. Okay, so these are the 2 values that we're going to use in the interval for the mean. And then our interval, it's going to be translated to the following. So in this case, and I need you to evaluate this in the calculator, your mean is going to be 25.688 plus or minus 2 times the 11.597. Okay, so let me tell you what I'm getting on my lower bound, and then we'll do a little bit of rounding. I'm getting 2.494. The upper bound is 48.882. So if you were to round to the nearest, so if we were to round to 1 decimal, this one we would say that, let's see, so 2.5 to, this one's going to go to 48.9. And if we were to go to the nearest, you could end up with 2 or technically 3. In this case, I'm just going to round to 3 to 49. And remember that these are text messages. Perfectly fine if you were to just look at the original 2.4 and ended up with 2. On paper, I'm okay on the rounding. Keep in mind that we do need a sentence. So your sentence would say that the usual interval is technically 3 to 49 text messages using x bar plus or minus 2s. And once again, your answer would be perfectly fine if you were to just went from 2 to 49. So on paper, I'm okay on the rounding. The software may be either looking for 3 to 49 or 2 to 49. Just something to keep in mind for that one. So that's actually it. The moment that they tell us that the data is bell-shaped, automatically the empirical rule kicks in. So for the usual interval or part A, this is all the work. Remember that your final answer has to have some sort of a sentence, as long as you mention that this is a usual interval and well, how you found it. In this case, that's the formula. Let me move on to the next part, which is also related. Now, the next part, because it's asking for 2 standard deviations away from the mean and it wants percentage. The spread is the interval. So let me just write it as this is just the interval. And the percentage, well, technically we don't have to do much work. So the interval with 2 standard deviations away from the mean. So let me just write that the interval with x bar plus or minus 2s ended up being 3 to 49. So technically 3 to 49 text messages. Now the percentage, for the percentage of data, we're looking at 2 standard deviations away from the mean, and from the empirical rule, 2 standard deviations away from the mean. That actually deals with number 2 here. We're looking at approximately 95%. So for this one, let me just write it out here. It's going to be approximately 95%. Now, because we're using a specific theorem, all of your conclusions need to have a sentence. And here we didn't have to do the calculation. This was already done in part A. So your sentence should say something along the following lines. By the empirical rule, we have approximately, in this case, 95% of data within 2 standard deviations away from the mean. And the interval ended up being 3 to 49. And then technically text messages. That is it for part B. There is nothing else that is needed. Let's move on to part C. In part C, we do need to do a calculation. So in this case, the interval, it's going to be x bar plus or minus the values of 3s, which is equal to our x bar that was actually used above was 25.688. And we're going to do plus or minus 3 times the 11.597. So this is going to give us the following calculation. So take a second and please punch it in. Okay, we do have a problem, but let me write it out. Negative 9.103 to technically, and the maximum I'm getting 60.479. Now here's the problem with this output, and let me double check the actual answer to make sure I don't have any typos. As we do the -3, this allows for the possibility of negative values. Now, the only problem with negative values is the data set. So our data set represents text messages. The minimum that anyone can receive in terms of text messages for the day would be 0. So in this case, we do have to do an adjustment for that problem. our final answer, we cannot rewrite it as a negative, even though the theorem allows for a negative. We would say that technically this will be 0 to, and let me double check, this is supposed to be at 60. So in this case, 0 to 60 or 0 to 61, 60 would be perfectly fine. If you round your final answer to 61, I'm okay with that. Okay, now the final sentence, and let me just write here the percentage. Now, since we are told that to assume that data is bell-shaped, you're looking at the third case from the empirical rule. Our third case, if your data is bell-shaped, the percentage of data within 3 standard deviations away from the mean is 99.7. So in this case, the approximate data, it's going to be 99.7. Your sentence, once again, it's going to pretty much say the same. You can rewrite it in any format, but you have to include the empirical rule, approximately 99.7. And this one has 3 standard deviations away from the mean with an interval of technically 0 to 60 text messages. And once again, in your interval, somebody could have done a original rounding of 1 decimal and then just rounded again to 61. So I'm perfectly fine from 0 to 60, 0 to 61. That's just a little bit of rounding. If we had carried more decimals, we would have ended up with possibly 61. So just something to keep in mind. The part that does need to be adjusted here on part C is the negative. You cannot conclude that there's a possibility of a negative text message, since technically our data set starts at 0 and then it moves on into the positive values. That's actually it for part C.